Good morning. In this example, we're going to continue our topic of evaluating limits. We're going to try direct substitution. That will not work, so we're going to talk about algebra techniques and then go back to direct substitution. So remember, direct substitution means we plug in directly for x. Once you plug in a number for x, you drop the limit notation. So this becomes square root of 9 minus 3 all over 4 minus 4. We know the square root of 9 is 3, so 3 minus 3 is 0. 4 minus 4 is 0. This is indeterminate. When we get to the topic of derivatives, we can use L'Hopital's rule for indeterminate limits. However, we're not there yet, so we're going to focus on algebra techniques. So let's start by first rewriting the limit. Now, we're going to multiply top and bottom by what I consider the fraternal twin of the numerator. So fraternal twins look alike, but they have some differences. They look like siblings, but they're not exactly the same. So notice here, I keep the two terms the same, but I change the sign in the middle. So instead of minus, it's a plus sign. And I need to make sure I do it to top and bottom. This is what we call manipulating the expression without changing the expression. It looks like I'm changing it, but because I'm multiplying top and bottom by the same thing, I'm actually multiplying by 1, which means I'm not really changing it, even though it looks changed. Now, let's go ahead and simplify this out. When we simplify this, you'll notice that I am going to multiply out the numerator, but I will leave the denominator alone. So because I'm going to leave the denominator alone, I'll go ahead and rewrite it real quick. Now, let me go ahead and FOIL out the numerator. So the square root of x plus 5 times the square root of x plus 5 is just x plus 5. That falls down. Square root of x plus 5 plus 3 is 3 square roots of x plus 5. And then minus 3 square roots of x plus 5. Then minus 9. So the limit as x approaches 4. Again, do not multiply out your denominator. Leave it alone. Go ahead and cancel and combine your like terms in your numerator. And what do you notice? We have similar factors. So in the numerator we got x minus 4, in the denominator we got x minus 4. So I can rewrite this again as the limit as x approaches 4, 1 all over square root of x plus 5 plus 3. So understand that this expression is the exact same as this expression. The only difference is now when I do direct substitution, and I plug in for the 4 everywhere I see an x, so I drop the limit notation because I'm plugging in the 4, I have 1 over square root of 9 plus 3. Well, the square root of 9 is 3, so 3 plus 3 is 6. So this becomes 1/6. So remember, always start with direct substitution. Plug in the number for x, or whatever variable they have here. If you end up with a 0 over 0, or an infinity over infinity, this is indeterminate. And because it's indeterminate, we're going to use algebra techniques to manipulate the expression so that we can go back to direct substitution. Once we go back to direct substitution, we actually get the value. So hopefully this example was helpful to you. Have a good day.